Very good morning, students. Welcome to the another first video of online classes. So in the previous video we have discussed about the refraction of light at plane surfaces, and this is the part 2 video of chapter 4. Okay, so in the previous video we have learned about refraction of light, laws of refraction, and in this video we'll have a discussion on speed of light in different media, relationship between refractive index and speed of light, and the rest of the things we will discuss in the next video. Okay, so let us start with the topic speed of light in different media, relationship between refractive index and speed of light. Okay, so in this we will have some sub contents also, and these are conditions for a light ray to pass undeviated on refraction, and relation between wavelength in the two medium, and also factors affecting the refractive index of a medium. Okay, so let us begin. So you all know that the speed of light is maximum in vacuum, and which is equal to 3 into 10 to the power 8 meter per second, and the speed of light in air is nearly the same as in vacuum, and it is denoted by the symbol c. So small c you have to write. Okay, and it is denoted by the symbol c, small c. Okay, so small c represents the speed of light in vacuum or in air, we can say. So in other transparent media, the speed of light is less than that of air or vacuum. Okay, so we know that the speed of light is maximum in vacuum and little less in air, but these two are approximately equal. Okay, so we can say the refractive index of a medium defined with respect to vacuum or air also is called absolute refractive index, or simply you can say the refractive index. Okay, so of the medium. So how to define the refractive index of the medium? So it is defined with respect to medium with respect to vacuum. Okay, so it is denoted by letter mu, or you can also write small n. Okay, this letter is mu. Then we have the absolute refractive index of a medium is defined as the ratio of speed of light in vacuum or air to the speed of light in that medium. Okay, so absolute refractive index is a ratio of the speed of light in two different mediums, but it should be the ratio of light in vacuum to the ratio of light which you want to find for the medium which you want to find the absolute refractive index. Okay, so for that we can write mathematically like this: mu is equal to speed of light in vacuum, or we have symbolized with a small c, and divided by the speed of light in that medium. Okay, so this gives the absolute refractive index. Then the absolute refractive index of a transparent medium is always greater than 1, because speed of light in any medium is always less than that in the vacuum. Okay, so you know that because c is maximum, light travels speed, or light travels in very speed in vacuum and air only. Okay, so that means always c is greater than v. Okay, so then we have the refractive index of glass is 1.5. It means that the light travels in the air 1.5 times faster than the glass. Okay, so here the refractive index is more, that means the speed of light in that medium is less. Okay, then one example we can take: the speed of light in air is 3 into 10 to the power 8 meter per second, and in glass is 2 into 10 to the power 8 meter per second. So the refractive index of glass we can find like this: mu glass is equal to the speed of light in air divided by the speed of light in glass. It will gives you 1.5, and we know that the refractive index is the ratio of similar quantities. That's why it do not have any unit. So this is do not have any unit, so no unit. Okay, so adjust with the handwriting, because I am writing in the mouse pointer, that's why the writing should be like this. Okay, you can adjust, no unit written here. Okay, so the second example you can take: the speed of light in water is 2.25 into 10 to the power 8 meter per second. So refractive index can be calculated by the ratio of speed of light in vacuum, which is or air, which is 3 into 10 to the power 8 meter per second, and water is 2.25 into 10 to the power 8 meter per second, and 2 times equal we have here, so we will cut one equal sign. So it will gives you 1.33. Okay, so from these two we can say that I already told that if the refractive index is more, then the speed of light is less. So in glass it is 1.5, in water it is 1.33. That means less refractive index gives more speed of light. So the speed of light is more in water than the glass. Okay, so then we have refractive indices of some common substances. Okay, so let us see the table. So air is given 1.0003. So this one approximation value we are taking 1 for that one, and ice, water, alcohol, kerosene, fused quartz, turpentine oil, benzene, crown glass, and also Canada balsam, and rock salt, carbon disulfide, dense flint glass, then ruby, then sapphire, then diamond. Okay, these all are given, and the refractive index of diamond is maximum among all the materials. Okay, then we'll discuss about something. So the refractive index of second medium with respect to first medium is related to speed of light in the two media as follows. We can write like that: 1 mu 2, that means speed of light in medium 1 divided by speed of light in medium 2. Okay, so you are getting what is the meaning of 1 mu 2? That means speed of light in medium 1 divided by speed of light in medium 2. Okay, and so here mu 1 2 or 1 mu 2 represents the refractive index of medium 2 with respect to 1. So mu 1 2 can be read as refractive index of medium 2 with respect to medium 1. So mu 1 mu 2 means refractive index of medium 2 with respect to medium 1. And if v1 is the speed of light in first medium and v2 is the speed of light in second medium, then we can write 1 mu 2 is equal to v1 by v2, and we know that we can multiply or divide by c, then we will get c by v1 by c will do here, and v2 by c will do here. If v2 by c is to be taken to the numerator, then it will be c by v2, and v1 by c is taken to denominator, it will be c by v1. So we know that c by v is mu 2, because we know that the ratio of speed of light of vacuum to the medium is mu 2, that means medium 2. Then this one is medium 1. So 1 mu 2 can be written as mu 2 by mu 1. Here mu 1 and mu 2 are the absolute refractive index of the medium 1 and the medium 2. Okay, if you want to find the medium, if you want to find the refractive index of medium 2 with respect to 1, then you simply find the ratio of refractive index of medium 2 by refractive index of medium 1. So this one is absolute refractive indexes. Okay, so then we have some examples for that. If refractive index of glass with respect to water has to be calculated, then what you will do? So water mu glass, that means speed of light in water divided by speed of light in glass is equal to 2.25 multiplied by 10 to the 8 divided by 2.2 into 10 to the 8. So it will give you 1.125. Okay, so this one is water. This one is the refractive index of glass with respect to water. Okay, second with respect to 1, we will read like that. Okay, and this is this we got 1.125. Okay, then next example we can take refractive index of water with respect to glass. Then we will find the reciprocal of that one. Glass mu water, that means refractive index of water with respect to glass. So here what you will put? Speed of light in glass divided by speed of light in water. So now we put the values of speed of glass in and water. Then we will get 0.89. Okay, so 0.89 is the refractive index of water with respect to glass. So there is a note is here. If the refractive indices of medium 1 and medium 2 are same, the speed of light will be same in both media. Okay, the speed of light will never change for a same medium. Okay, so the ray of light will pass from medium 1 to the medium 2 without any change in its direction, even when the angle of incidence in medium 1 is not 0. Okay, so if the angle of incidence is not 0 and the two different medium is same, then the refraction ray will be always go in a straight line. Okay, so then we have conditions for a light ray to pass undeviated on refraction. Okay, so there are two conditions for that. Okay, from medium 1 to from medium 2 we require two conditions. The first one is when the angle of incidence at the boundary of two media is 0. Okay, so when the angle of incidence is 0, then the light ray will pass undeviated on refraction. Okay, that means it will not change its direction. And the second point is what? When the refractive index of two medium are same. We have already discussed about in the note about this. So when the refractive index of two medium are same, then the light will be undeviated and the light will be do not change its direction of light. Okay, so then we have relationship between wavelength in the two medium. Okay, so how to find this one? So if a ray of light of frequency f and wavelength lambda suffers refraction from air to a medium in which the speed of light is v. Okay, so speed of light in air is taken as c and speed of light in that medium. So what is the medium? We don't know. We have to take one medium. That medium is what? V. Then the frequency we can write f is equal to c by lambda. Okay, where lambda is the wavelength. Okay, for the medium, for air we can write the frequency f is equal to c by lambda, but for the medium f is equal to v by lambda dash. Okay, which is the wavelength of the light in the medium. Okay, so now c by lambda is equal to v by lambda dash. Okay, because we know that the frequency is remaining same in the process of refraction. Okay, so we can equate these two, then we can find lambda dash is equal to v by c lambda. Okay, we just take this lambda, where is the cursor? Take this lambda dash to this side and lambda by c to this side, then it will be v by c lambda. Okay, so but c by v is what? We know c by v is equal to mu, which is refractive index of the medium, but here it is v by c. So you can write c by v, then lambda by then what can we write? We can write lambda by c by v, or we can write lambda by c by v means what? C by v means mu. Okay, so we can write like this: lambda dash is equal to lambda by mu. Okay, then lambda, we got lambda dash is equal to lambda by mu. That means the wavelength in the medium is equal to wavelength in air divided by the refractive index mu. Okay, and obviously we know that if mu is always greater than 1, because it is 1 only for air or vacuum. So the wavelength lambda dash is always less than lambda. But if the light passes from a denser to the rarer medium, then mu is always less than 1, then the wavelength will be increased, so lambda dash will be greater than lambda. Okay, so from rarer to denser, the wavelength decreases; from denser to rarer, the wavelength will be increased. Okay, then we will have some factors affecting the refractive index of a medium. So what are those factors? So there are 3 factors upon which the refractive index of a medium is depending upon. The first one is what? The first one is nature of the material. Okay, or nature of the medium also we can say. So the speed of light in a medium as compared to the air is less. So more is refractive index of medium, then less is the speed of light. Okay, so then the next one is what? The next one is color or wavelength of light used. Okay, so the speed of light of all the colors in the same is the same in air, but any other transparent medium, the speed of light is different for different colors. Okay, the speed of light is different for different colors in any other medium other than air or vacuum. Okay, so in the given medium, the speed of red light is maximum and that of violet light is least. Okay, therefore the refractive index of the medium is maximum for violet light and least for red light. So we can write mu v, we can write mu v is greater than mu r. So mu v for refractive index of violet, this one for refractive index for red light. Okay, so the wavelength visible light increases from the violet to the red end. That's why, so we can say that the refractive index of a medium decreases with the increase of wavelength. If wavelength will increase, then the refractive index will be decreased. Then we have the last one, which is physical condition such as temperature. Okay, so if the temperature is increases, then the speed of light in vacuum is also increases. Okay, so it leads to the refractive index will be decreased. So okay, if temperature will be increased, then speed of light will also increase, then refractive index will be decreased. If temperature will decrease, then speed of light c will also decrease, then refractive index will be increased. So this is the effect of temperature. Okay, so I hope you all understood about these topics. In the next topic we'll discuss the rest of the things. Then till then, thank you, have a nice day.